Okay, I thought I'd do a quick video for Dr. Paez um, to know how to do the MANCOVA analysis on SPSS. So let's share the screen. Okay, so we have a very cool study with FISMAC grant, which we have the data collected already, and to do MANCOVA analysis, which is MANOVA, and we including the covariant onto the MANOVA. So we first need multiple dependent variables, which is we have 3 different kind of food safety behavior with 3 questions. Usually we consider the different self-reported behavior, but we have an intention. People saying like they intend to perform food safety behavior, which we suspect it should be there should be significant differences on the fixed factor, which is the intention, on different type of food safety behaviors. And then we have different demographics. We have the gender and age. Maybe can be not age is string variable. So about education level and employment status, which we are using it as control variables for MANCOVA analysis. So first, let's do go to the analysis, go to general linear models, and go to multivariate, and click on multivariate. Let me remove this. Okay, so we want to know, so the dependent variable, we have 3 different types of food safety behavior, self-reported food safety behavior, and we have more than 1 dependent variable. I'll put it here. But we expect the intention will be causing significant differences in different type of food safety behaviors. So we put it into the fixed factor, which is using it as an independent variable to see if they can cause significant differences in 3 different type of food safety behavior. Then we have covariant, which is control variable, who can be used for MANCOVA analysis, and we suspect we need to control the gender, and we control the food safety certificate as a control variable, and we have education level and employment status as control variable. So we go to the model, we can specify specific model for interaction or main effect. But for this first step, we just looking at the full factorial model, and the sum of squares should be click onto type 3, and including intercept in the model, and then we click continue. For contrast, we not doing contrast in anything right now because we're doing full factorial model. And plot, we don't need to plot anything right now because we haven't seen the results. And the options, we want to click on descriptive statistics, which can tell me which group of food safety behavior have the higher mean or standard deviation. And we want to have the estimate of effect size. So we know the effect size value and the SSCP and SSCP matrix, which is tell us the mathematics process for MANCOVA, which if the people can backtrace the statistics conducted in SPSS, they can use the SSCP matrix. We also want to know if the multi-group have the same heterogeneity or different heterogeneity ratio. So we click on the heterogeneity test, and we click on continue. And generally, we want to do at least if the computer power allows, which my computer is slow, and you should at least do like 2,000 to 5,000. And we ideally we want to have 10,000 bootstrapping to be done to achieve a more normalized and to have a big sample size, and just to let the test to be more rigorous. So then we click on OK. Boom, it runs. Yay. Okay, so the first table is telling us the descriptive statistics, which is a lot of people mentioned the self-reported food safety behavior is somewhere false. A lot of people say it's not true. I was doing it, doing the food safety behavior, which is pretty scary. Oh, no, I read it wrong. Sorry, this is standard deviation. And most people say it's definitely true. I'm doing the food safety behavior. Okay, we feel safe now. So this is the box text, which is to see if there's more multivariate normality, which this non-significance means we have multivariate normality, and with significance, saying like we have violated normality, the data is more skewed. I mean, looks like more people having choosing yes. They do, so it's more positive. It looks like it's more skewed towards positive. So this is understandable, but we can do post hoc on that to see if this test is rigorous or not. And this is interesting that the heterogeneity test have shown significant, so there's significant differences between the 3 different types of food safety behaviors. And this is the main result. This is a multivariate test, which is the main results, which we are using intention. This one is to test if intention has significantly caused different food safety behaviors. It looks like our test is significant with a very it's a somewhat big F value, and with a very significant result. Looks like the intention, food safety intention is causing is significant differences in different type of food safety behaviors. Which is the Levin's test is post hoc and telling us which one is which the differences between looks like the intention is especially strong on the second type of food safety behavior, but overall the costs all 3 different food safety behavior to significantly different from each other. And this is the test of between subject effects, which is the ANOVA test to see, like here we have food safety behavior 1, food safety behavior 2, and food safety behavior 3, which all showing significant different from each other. That's why we have the significant results. And this one can be generated, but we don't have to interpret it for this matrix. So that's concluded the MANCOVA test, which is if we have a significant results on the multivariate test, then we want to look at specifically each univariate ANOVA test for each behavior to see the differences. And generally speaking, we want to report the Hautelin's choice which is more rigorous, or the PLIS trace, which is more rigorous, and we want to report the F value, the degree of freedom, and the partial eta square, which is equivalent to the R square of the normal test, but this is multivariate, so it's using a different statistic, but looks like it's at least expanding 10% of the variances in the report. So that will conclude how to do the MANCOVA test. I hope Dr. Paez, you will like it. And let me stop it.